Hi, you're watching Business Data Science course episode number 5. This episode is about anomaly detection. So anomalies are something which is shouldn't be there. You're looking for outliers, you're looking for example, illegal transactions in finance, you're looking for different stuff in insurance. You might be working in the industry, you're manufacturing stuff, and you're looking for example, you're producing jeans, you're looking at the factory line through the camera, and you want to detect all the anomalies, all the jeans, for example, which didn't pass the quality test, and you want to do that automatically. So you want to build a system which achieves that and detects anomalies automatically. And the good answer is that it's all done with data science, machine learning. There are different techniques for doing that, and we're going to cover that in this episode. So basically, you can divide the data into two categories for the purpose of this video at least, numerical data and data related to photos. Those are two different scenarios. So basically numerical data goes with finance, insurance, and cybersecurity, because this is also a big issue. So whenever you're trying to predict, for example, the safety of your web or your net, internal network, you're trying to see whether there are any hackers trying to break into, or you're trying to test your cybersecurity. You're looking for anomalies, you're looking for outliers in terms of behavior. It's the same kind of a problem when it comes to insurance, where you're trying to see people who are actually trying to do strange things, and trying to cheat in order to get money out of the claim, or in finance, some kind of a stolen identities and people trying to do illegal transactions. That's all numerical data, because you have only numbers, you have only this data about different purchases, different transactions done in the digital world. On the other hand, in the factories or in the industry, you will have data coming from cameras. So you will have photos, videos on different objects which are going through the factory line, and you will be looking for actual anomalies in terms of a physical product. So for example, you're producing hardware, you want to make sure that all the chips are in place, or the components are in place, everything is working well, great. This is the kind of a problem you'll be looking at. This is all about anomaly detection. So when it comes to the second thing, so the thing with industry and photos, images, videos, it's mostly about using neural networks in form of the autoencoders. That's the most standard technique to start with. I've mentioned that briefly in the previous episode, but this is really where autoencoders are used. You want to compress the data and then decompress it, because when you compress the data, then actually you can really easily compare that to the standard. And once you have the, for example, compression of your hardware, the photo of your hardware, then you'll be able to determine whether it's leaked, or whether there's something invalid about this piece of hardware. And again, that works the same for jeans, for wires, for whatever you're producing on scale. On the other hand, with numeric data, you use a little bit different techniques for trying to understand whether there are any anomalies. One of the standard things you would do is, again, the dimensionality reduction, the thing I've mentioned before, because you need to, again, scale down your data, see whether you can see any similarities at this scale, and only then progress with trying to find who's an outlier, who's not. The very basic technique is actually PCA, so principal component analysis, where you actually try to project the data on a couple of different axes. You can think about it as looking at different parameters one at a time and ignoring the rest. So it's like doing really the test of your data from different angles. This is something which works really well at the beginning, at least, and can really well replace the manual checking of different transactions, different claims. This is really useful. Only then you can come to more advanced techniques like neural networks, because this is really helpful. In the end, deep learning allows you to give predictions about the stuffs, and here you want to predict whether something is valid, invalid, whether it's spam or not. This is really useful here. So this has a little bit of the connection with the supervised learning we talked before, and classification problems, because anomaly detection is about classifying objects into those which are standard, classical, normal, and the others, and then you want to inspect the others. So the problem for looking for anomalies is really great for machine learning, because you can really use all the techniques, and data scientists that you need for anomaly detections are a little bit more advanced, because especially if you have tricky data, for example, if you have photos of more advanced numerical data, then there's a lot of problem solving involved with cleaning this data, with trying to see different dependencies between this kind of object, this kind of parameters. There's a lot of work to do actually, and there's no one good solution, because anomaly detection is about anomalies. It's very unique. You really need to tune known algorithms for your problem, for your data. It's a little bit more complex. But again, this is something very standard, which is happening in business all over time, either in industry, in finance. This is everything. This is everywhere. And yeah, this is very, very crucial. Thank you for watching this episode. The last episode will be the next one, and this will be about getting data, acquiring data, and how to visualize everything. So I want to end on this nice note of having data presented to you in the nice form. Thank you for watching, and see you in the next episode.